what I want to do is I want to compare the brain to a computer. It's not a really perfect comparison. Disclaimer, okay? The human brain is very complicated and dynamic and all that kind of stuff. But generally, we're just going to take a look at the components of a computer and look at how the brain is like a computer, okay? Because it's going to help us understand this whole habit and willpower conundrum and how choosing happens, which will help us understand what is inside of our control and how to manage that, okay? So if we have a computer, the computer begins with the CPU, right? This is the part that actually does the thinking, the computing. The problem with the CPU is that it has very limited space to hold information in. I'll give you an example. Remember these numbers for me, okay? 7, 13, 25, 6, 49, 56, 83, 76, 5, and 2. That was only 10 numbers. It was only 10 numbers. That's not a lot of information, right? But there's not enough space inside of the CPU to hold all that information. I'm going to write it down on a piece of paper so that the information is held over here, and then when I want it, I can go over and access it on this piece of paper that I have, right? So the computer needs outside memory to hold information while that it's not actually using to compute. And there's two kinds of memory. We have memory and then we have storage, okay? Memory and storage. Back in the day, we would call this RAM and this ROM. However, once again, things have become a lot more dynamic now, so this isn't a perfect comparison, but memory and storage. Now, the fourth component of our computer is the power supply, the battery, right? The power supply. And if you have these four things, now you have the Apple II, okay? This is what Steve Jobs is famous for creating, is putting something that had all four of these on every desk in the country, on every, putting one of these computers in every home in the country. You have a computer with these four components, okay? Now, I want to talk about these two different kinds of memory and help us understand the way these two different kinds of memory are the same, but also the way that they're different. So the first difference that they have, if you have your cell phone, your average cell phone today is going to have probably 2 gig of RAM. If you have a really nice one, it's going to have more, okay? But it's going to have 64 gig of storage. So you see the discrepancy. Only 2 gig of memory, 64 gig of storage, okay? So that's your average cell phone. If you get a really nice cell phone, or if you buy, a nice computer, you might have 16 gig of memory, but then you'll have like 1,000 gigabytes of storage. Once again, you notice the discrepancy, right? The discrepancy between memory and storage. For human beings, we're very similar. We have very limited memory. Very limited memory. But we have virtually... Say that again?
200 gigabyte. Yeah, this can hold 200 gigabytes.
Of information. So that's your storage, right?
Mm-hmm.
Yeah. That's your available storage, probably. So for humans, we have the same discrepancy. We have very limited memory, but we have virtually unlimited storage. The scientists, psychologists, they cannot figure out where human beings store all of the information that we store. There's only 600 billion cells in the human body on average, right? We store more information than those 600 billion cells can hold. And so that's one of the mysteries of the human mind, is how do we store all of this information? In fact, the religion of Scientology was founded trying to answer that question. Where's all the information that they're storing? Interesting fun fact. So another difference between memory and storage, okay? RAM, this is volatile. What that means is if I disconnect the power supply, it cannot hold information. Storage, ROM, this is not volatile. It does not need the power to be connected in order to hold information. So like a CD-ROM or a record can store information even if it's not hooked up to a battery. Right? Does that make sense? The other difference is that RAM memory uses lots of power. Okay? ROM memory uses very little power. So ROM is virtually unlimited. It uses very little power, and it can keep information even when it's not being connected to the power supply. So why would RAM even be cool? The reason we like RAM is because it actually interacts with the CPU. You can interact with the CPU in read and write functions. So you can change the information that's in the RAM. It's random access, and you can access any part of this memory and change it. Okay? And you can write new things there. ROM memory storage is read-only memory. That's what ROM stands for. Read-only memory. So whatever is there, and you can't change it. That's the disadvantage of ROM. Okay? So ROM actually has to be connected to the RAM. Okay? The problem with that is that write functions also use a lot of battery, and so that causes RAM to use even more battery. Okay? So what the RAM does is it loads programs from the storage and allows them to interact with the CPU. So to grab information from over here that's read-only, put it over here, and then allow that to interact with the computer. Does that make sense? We understand this? Okay. So for example, if you have Windows on your computer, right? That's a huge application that's stored in the storage of your computer. Probably takes up, I don't know, 100 gigabytes of space, Windows, okay? When you turn your computer on, the RAM of your computer, probably about, depending on how much RAM you have, probably about 20% of it will be used just to run Windows and allow the CPU to begin interacting with the operating system, okay? We're going to call the portion of your RAM that you use to load these programs, we're going to call that ops, okay? And then we're going to call your operating system, any of the programming that came with you before you were born, right? We're going to call that instinct. And then any applications that came after you were born, we're going to call that habit, right? These are the learned things. All of these habits, they work the same way as the operating system. They come over here and use ops to interact with the CPU. Does that make sense? We following this? And then the portion of our RAM that is left over, we're going to call active memory. Active memory, okay? That's extra memory that is left over. And then we're going to call this battery willpower. So now, instead of having a computer, we have a person. Okay? Same systems, same relationships, same connections, just a person. Okay?